but they're not that bad once we get the hang of them. Most of this is review, though. Well, that's not in very good focus. Real numbers and number lines. Let's struggle. Okay. So we'll start by talking about rational numbers. And irrational numbers. What does the book say the definition of rational numbers is? Can anyone tell me? Yes.
A number that can be written as a fraction.
What does it say the definition of irrational numbers is? Anybody?
Two decimals, non-terminating, or do not repeat?
Non-terminating and non-repeating decimals. Now, my question to you is this. What does non-terminating mean? Not ending. It doesn't stop. Non-repeating means it doesn't repeat the same pattern. You guys think of a fraction that's a repeating decimal that you put the bar over. Usually one of two usually comes to mind. Anybody? How about 1/3? What is that equal to? When you put that into your calculator, it's 0.3 what? Repeating. See, that can be written as a fraction. It goes on forever and ever, but it repeats. So it's not an irrational number, it's a rational number. Now, of course, another example of a rational number would just be the number 2, right? How can you write 2 as a fraction, though? Over 1, right? There's all kinds. Another one that repeats and goes on forever, 2/3, which is what? 0.6 what? It's a decimal that is non-terminating, but it is repeating. So it's a rational number. Now, we always have problems explaining things we can't see or we can't write down. And that's the problem people have with irrational numbers. Is it actually possible to write down an irrational number? Yeah, it actually is, but you couldn't write it in decimal form. Why? Well, one, you're not going to live forever, are you? I hate to break it to you, but you're not going to live forever. Well, an irrational number is. You could keep writing numbers and numbers and numbers and numbers, and one day you're going to die and can't write any more numbers. And therefore it terminated, didn't it? Because you stopped writing that day, didn't you? As morbid as that sounds, the point I'm making is that you can't really usually write them down in decimal form. So it's tough to understand what they are. Well, usually there's a couple of special ones, and the special one, does anybody know the most popular or most famous irrational number? There you go. It's pi. It is a is a non-terminating, non-repeating decimal. Okay? You see, say I've taken pi out to so many decimal places. It never repeats the same pattern, and it never stops. Therefore, it's an irrational number. Now, the most common type of irrational number you're going to deal with deals with square roots. For instance, square root of 2 is an irrational number. And this is not in the book. That's an irrational number. Square root of 3 is an irrational number. However, I'll tell you a rational number, square root of 4, that is a rational number. Does anybody know why? Because what is square root of 4? Square root of 5 is an irrational number. Square root of 6 is an irrational number. Square root of 7 is an irrational number. Square root of 8 is an irrational number. The square root of 9 is a rational number. Why? Because the answer is 3. What number do I square and get 9 is the answer 3. So the next one would be square root of 10, so on and so on. Those are some examples of some irrational numbers. Okay? Just leave it at that, and that's it. Now, in the book, they're going to ask you to do some examples, and we'll talk about those here in a little bit. Number line. How many of you remember number lines? You should. It's a line remember, it has an arrow on each end. You usually have 0 somewhere. What number would I put here? Here. How about here? You guys okay there? That's an example of a number line. What we're going to do today is find the distance we're going to do problems like this. I'm going to ask you to find the distance. I'm going to find the length of BD. How far is it from B to D? Can anybody tell me? How did most of you get that? Did you worry about these numbers at all? You went to right here, and what'd you do? 5? You counted, didn't you? That's a great way when you have something this size. The question is, what are you going to do when you can't draw a number line? In other words, do you guys want to draw a number line that's from negative 200 to positive 200? And then count the distance between one way over here in the negatives and way over here in the positives? You guys want to sit and count that? No, so there's got to be a way to do this just with the coordinates. And the way to do it is, what you do to find the distance from B to D, first of all, distance is always positive, so what, you're going to see absolute value signs, because that's the distance the number is from 0. That makes everything positive, does it not? What you do is you take the coordinate of B. What is B's coordinate? And you subtract the 2 coordinates. What are the coordinates of D? 3. Now, what happens here? Negative 2 minus 3 is a what? Negative what? Absolute value of negative 5 is what? We got the exact same answer, didn't we? That's how you do it. So I should be able to say B, something has a coordinate of 400 and the other one has a coordinate of negative 200. What's the distance between the two? You'd go 400 minus what? 200, and you'd get 600. Okay? This is how I want you doing it on your assignment. Does everyone hear that? I want to see the absolute value. I want to see you subtract. I know you can count. I know you can do that. But this is the part that's more useful because this can be used in any situation, can it not? Okay, so this is what I expect to see. Now, what would be a great way to check your answer? Go up here and what? Count. Okay, looks like I was right. How about FB? Or the distance from F to B, the absolute value. What is the coordinates of F? Minus, what is the coordinate of B? What do I end up having here? Minus a what? So this becomes what? Negative 5 what? Plus 2. Absolute value of what? What's the answer? That's the distance between those. Count it up. 1, 2. You're right, weren't you? That's pretty easy, isn't it? We can do that, can't we? Everybody get that worksheet out? I know they have an X on them, but we are going to talk about them. A rational number less than 0 with a 3-digit repeating pattern. These always throw people off because I'm asking you to be creative. They're giving you conditions. Make sure the number you give back satisfies the conditions given. So is there going to be more than one right answer here? Absolutely. Think about it. There's a lot of rational numbers that are less than 0 with a 3-digit repeating pattern. So what does less than 0 mean? It's negative. So it needs to be a negative number, and then 3-digit repeating pattern means 3 digits that repeat, right? So first of all, what's my number going to need to be? Negative. Okay. Negative, you want to say negative 2 point something. Now's when the what? 3-digit repeating pattern happens, right? What would you write down to give me a 3-digit repeating pattern? No. What you're going to do is pick 3 digits to repeat. The thing is, you can't really be wrong here. Okay, what if I said 3? Then what do you want the next digit to be? Nope. 4, and then the next one. 5. Then show the pattern what? Is that not? Okay, is this number less than 0? Does it repeat? Does it have 3 digits repeating a pattern? So did it satisfy the conditions? That is a valid answer. I put ... to indicate it goes on forever and ever. Now, I guess, unless they ask you to take it to a certain number of digits, you could do something like this, like a negative 1.159, and then put, I guess, a line over it for repeating, couldn't you? Wouldn't that be an answer too? So I just picked 3 numbers and put them in there, didn't I? But you got to ask yourself, does it, satisfy the conditions? So there's an infinite number of answers people could put on there, isn't there? But everybody always struggles with, okay, they're asking me to be creative. Irrational number between 7 and 8. Oh, it asked me to take it to 10 digits, didn't it? So how many did I take this one? So I took it to 3, 6, 9. What should I put here? 3 would be the next one, wouldn't it? So this would actually not be right, because they said to take it to 10 digits, didn't they? Everybody see that? With 10 digits to the right of the decimal point. Okay, so an irrational number between 7 and 8. It can't repeat a pattern for those 10 digits. Okay, and it has to go on forever and ever. So it's going to be 7 what? Point something. Give me a number. 5. Another number.
2.
Another number. 2. Huh? And a good way to kind of distinguish that there's not a pattern is, you see how we started with a 5? Go with a 5 again, and then instead of the next one being 9, make it something else. Give me a number.
4.
See how we're obviously not repeating a pattern here? Where do you want to go next? Give me one more. Okay. I guess in a way you gotta go dot, dot, dot there to let it know it goes in front. You know, this is the book letting you, I'm not gonna make you write a square root there. Really the best, perfect answer there would be like square root of 52. Is the way I'd want you, if in a, eventually you need to get to that point, but it's asking you to take it to digits, but this is fine. You're just trying to demonstrate what? That it's irrational, so it doesn't repeat a pattern, does it? And it goes on for 10 digits and goes on forever and ever. Two irrational numbers between -1 and 2. So -1 point, I got to take it to 10 decimal places, and it's what kind? Irrational. So can I repeat a pattern? No. So give me some numbers. 5, 2, 3, 7, 8, 6. At some point, probably need to repeat a number and go with a different pattern. 2, and then what do you want to put at next? 6. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. Okay, very good job. But they asked for 2 of them, so guess what? You're going to have to go -1 point. Then you need to pick what? 10 more. Pick a number. Something besides 5. 8. You guys, pour 0. You forgot about pour 0. What's next? Oh, I can't put 0 in, can I? Oh, yeah, I can. 0, and then what? 2. What next? 0. Give me another one. 1 more. 8? We always seem to start right at, we write a bunch and then we decide to count them and we're at 9, aren't we? So those are 2 examples of that. Any questions? Hey, can you guys do these? What have they done different here? What do you need to pay attention to? These are halves, right? This is -1 and what? And this is negative what? And this is 1 1/2, 2 1/2, and this is -1/2, 1/2. Okay, one thing about these is, and that's the nice thing, if you got those calculators I told you to, you can just you can actually put them in as mixed numbers and subtract them. But those of you that don't have calculators and can do fractions, you need to remember, truly to subtract these, you're going to need to write them as an improper fraction. Kind of. You ought to be able to count the halves anyway, but F to I. Okay, I'm absolute value of 1 minus, what's the coordinate of I? What's the absolute value of -2? What's the answer? 2. How about D to H? What are coordinates of D? -1/2 minus, what's the coordinates of H? 2 1/2. That'd be a -3. So what's the distance? A to I. What's A? Can anybody tell me what the coordinates of A is? Minus, what's the coordinates of I? Huh? What would this be? The absolute value of negative what? 6 1/2. So what? 6 1/2 is your distance. Think you guys can do that? Now, what are they doing down here on number 12? And I'll you guys stop writing and I'll zoom it out and freeze it when we're done, okay? So you can finish writing down. So everybody stop writing. In Detroit, Michigan, the weather report says today's high was 3 degrees with a wind chill factor of -10. Find the measure of the difference between the two temperatures. Can you tell me if there's, in essence, any difference between number 12 and number 8? To find the difference between two numbers, basically this is a number line, isn't it? You've got one with a coordinate of 3, the other one with a coordinate of what? To find the difference, I'm just going to, and I'm finding the difference between the two, so it's can't be a negative number. Same thing. So absolute value of 3 minus what? Negative what? It'd be 3 what? Plus 10, which would be 13 degrees apart. And if you think about it, the difference would be 3 more to get to 0 and then 10 more to get to -10. That's 13 marks you went, isn't it? So these problems are really the same. It's just what? They're giving you the coordinate instead of writing it on a number line, aren't they? So you got to subtract the numbers.